Architecture and structural engineering have advanced so rapidly in the last 2 decades that soaring skyscrapers have become a common sight in many of the world's largest and wealthiest cities. The race is always on. Within the span of just 2 years, the world's tallest building was built 3 times in New York City. The 282.5-meter Bank of Manhattan in 1930, the 319-meter Chrysler Building in a few months after, and then 11 months later the 381-meter Empire State Building in 1931. The era of architectural horse-racing and ego-boosting has only intensified in the decades since. This being said, the primary question is, how high can the world's tallest skyscraper go? For today's video, I'll walk you through the world's tallest skyscrapers. But before that, make sure to like and subscribe to this channel to show some support. And please, hit the notification bell to be updated for more videos like this one. Without further ado, let's get started. Number 5. Tokyo Tower of Babel. The Tokyo Tower of Babel is a futuristic 33,000-foot-high hyperstructure that was proposed for construction in Tokyo in 1992. Although it is unlikely to be erected in the near future, if it is, it will be the world's highest structure, exceeding Mount Everest by 3,968 feet. The Tokyo Tower of Babel is among the world's tallest projected structures. It was based on the biblical Tower of Babel, a construction capable of reaching the heavens. With as many as 30 million people living in this area, the Tower of Babel would reach a height of 10 kilometers and serve primarily as a population support structure. It would be mostly composed of steel and would take around 100 years to finish, costing $22 billion. The floors were mostly used for housing and commercial reasons. The 1 to 3 kilometer sections were meant for offices and hotels, while the 3 to 6 kilometer floors were designed for education, administration, and pleasure. The top part is for space exploration and solar energy, while the bottom part is for industrial, experimental research, and base facilities. Parking, power generation, and power plants are all housed underground. Number 4. Burj Khalifa. Burj Khalifa's architectural height is 828 meters or 2,717 feet, measured from the top of the spire, which is considered an architectural element of the tower. Before 2010, the height of the Burj Khalifa was kept a secret to prevent it from being surpassed by possible competitors. Finally, the owner MR declared the Burj Khalifa's standard height is 828 meters, with a total height of 829.8 meters at the tip, making it the world's tallest skyscraper in all categories. Burj Khalifa has held the title of world's tallest building for 10 years, and it will continue to do so for another 3 to 5 years until either the Dubai Creek Tower or the Jeddah Tower exceeds it in 2022 or later. Level 154, which is 584 meters above ground, is the highest occupied floor. There are 3 observation decks for public viewing, located on levels 124, 125, and 148 respectively. With a height of 555 meters, the one on level 148 is now the world's highest observation deck. The tower is built on a shamrock-shaped footprint, which gives it the appearance of a letter Y when viewed from above in the air. This form is derived from Hymenocallis, also known as the desert lily, a desert plant. The tower's cross-section area gradually decreases as it climbs. Number 3. Exceed 4000. The Exceed 4000 is a futuristic concept building that will rise 4,000 meters above Tokyo's skyline. Taisei Corporation designed the visionary skyscraper or sky penetrator in the mid-1990s. It mixes ultra-modern living with developing transportation technologies and engagement with nature to accommodate up to 1 million people. It's a structure that encapsulates the engineering community's futuristic vision as well as humanity's growth. Exceed 4000 is a self-contained city within a structure, a 4-kilometer or 2.5-mile high eco-utopian habitat with over 800 stories built in an open framework in the shape of a concave cone, aesthetically similar to Mount Fuji. Residents will never have to leave the building because it contains residential, commercial, and urban spaces. Because the construction is so tall, extra care must be taken to manage air pressure fluctuations throughout the structure in order to minimize altitude sickness. The Exceed 4000, unlike traditional skyscrapers, would have to actively safeguard its occupants from significant air pressure gradations and weather fluctuations along its huge elevation. Its design necessitates the utilization of solar energy to keep internal environmental conditions stable. Despite the fact that Exceed 4000 is the largest skyscraper ever completely designed, it is unlikely to ever be completed. It does, however, provide the incentive for not only improvements, but also inventions as we consider the material, environmental, social, and design requirements of such a vast construction. Number 2. The Launch Loop. Proposed electromagnetic launch systems from the Moon or the Earth involve extremely high accelerations that are only suited for raw materials. The electronics for high peak power is highly expensive. Orbital capture devices must be built with significant amounts of mass already in orbit or with material strengths that aren't currently available. The launch loop efficiently transfers vehicle energy and momentum compared to rockets with simpler vehicles. High-speed continuous material flows and electronically controlled ferromagnetic levitation are used in the launch loop. The inertia of the rotor supports and drives the system, and it is segmented to reduce axial tension. Large quantities of launch loop building components are commercially accessible. It is a long, narrow cross-section structure built around a 14 km per second segmented iron rotor loop. The rotor is a 5 cm diameter cylinder with a 2.5 mm thick walls. Once every 6 minutes, this rotor circles the system, going around the ends, up the inclines, down the launch route, and back down the incline at the other end. The rotor is deflected 180 degrees and returned to finish the cycle when it reaches the far end of the launch loop. Indeed, the sky is the limit. However, additional research is needed to identify the specifics of a launch loop operation. The concept could be unfeasible due to instabilities, cost, or political opposition. Regardless of its success, it is hoped that it would inspire others to consider low-cost Earth launch options based on existing physics and engineering materials. Drum rolls for number 1. Space Elevator. Konstantin Chalovsky, the same guy who came up with the renowned rocket equation that helped carry rockets into space, initially proposed the idea of a space elevator in 1895. A space elevator is essentially a long cable reaching from the surface of our planet into space, with its center of mass at 35,786 km height in geostationary Earth orbit. People, payloads, and electricity might be transported between Earth and space using electromagnetic vehicles that travel down the wire. To fight the gravity that would draw this massive 100,000 km structure down, as well as the centrifugal force and inertia of the counterweight, more on that later, a space elevator requires extraordinarily high tensile strength. It must remain stable and functional under high heat and cold, as well as unpredictable atmospheric forces and radiation from space. On top of that, it would have to withstand regular bombardment from micrometeorites and solar wind particles. The skyscraper will be built on an equatorial site, according to conceptual plans. The bottom tower section's extraordinary height makes it vulnerable to severe winds, because the area is virtually devoid of hurricanes and tornadoes, and it aligns correctly with geostationary orbits. An equatorial position is appropriate for a tower of such enormous height. Building a space elevator will be the most ambitious endeavor humanity has ever undertaken. Humanity always manages to outdo itself in terms of engineering prowess. We're always looking for the next challenge, the next obstacle to overcome. Building a space elevator may take technology and people that we can't even imagine today, but remember that flight was still a far-fetched fantasy for the human race 150 years ago. From that perspective, there's no knowing how close we are to constructing a 100,000-kilometer space elevator. These skyscraping buildings indeed set the standards for the height and features of future buildings to be constructed. Which among the world's tallest skyscrapers I've mentioned would you include in your bucket list? Let me know your thoughts in the comments below. Well, I hope you enjoyed today's video. Do not forget to hit the like button, share with your friends, and subscribe to the Luxe Luxury channel to show some support. Please also hit the notification bell to never miss any of our luxurious videos to be uploaded. Thanks for watching and see you on the next video.